myself Sandeep Kumar, 21 BMS 1131. I am here to discuss on the microcontrol systems project, automatic fire extinguisher. Automatic fire extinguisher is a simple control system which is used to prevent damages and injuries from fire by alarm and suppression by getting the temperature values from the surroundings, and it acts according to it. An automatic fire extinguisher is using a fire sensor and an Arduino microcontroller is an innovative device that can help to prevent the devastating effects of fires. The Arduino microcontroller combined with the fire sensor can detect fire's presence and trigger the extinguisher to release a fire suppressant, helping to reduce the risk of injury, loss of property, and even death. Fire disasters is a common threat to lives and property. An automatic fire extinguishing strategy provides real-time monitoring, exploration, and programmed fire alarm. This paper presents the design of a low-cost, robust, and secure fire protection system for buildings. It sends early alarm when the fire occurs and helps to reduce the fire damage. This system consists of a smoke detector and a temperature sensor whose outputs are connected to the controller. The system takes into account and density of the smoke, and thus the probability of false alarms can be avoided. In conventional automatic fire extinguishing systems, utilizing a fire extinguisher gas, a bomb containing a fire extinguishing gas such as halon gas under pressure of provided at a location. Several gas jetting nozzles are arranged at desired locations within a region when a fire occurs there. The gas jetting nozzles are connected through a valve and pipe to bomb. The fire sensors are arranged at desired locations within the region. In response to a fire signal from the fire sensors into the region so that the automatic extinguishing can be affected therein. However, since such as conventional automatic fire extinguishing systems require a complicated system of gas pipes from a gas bomb to the gas jetting nozzles, the cost of installation of pipes is more expensive. Moreover, since the gas pipes are fixedly arranged in the walls, ceilings, etc. of a room, defining a region, it is not easy to remove the gas pipes and to change the arrangements of the gas jetting nozzles. Furthermore, the gas bombs to be used most have a capacity comparable with the space of the region, and therefore gas bombs having different capabilities must be prepared for different regions. This is very uneconomical. To eliminate the drawbacks of which I have mentioned before, conventional fire extinguishing system, a portable automatic fire protection system is disclosed comprising battery-powered independent suppressor units, each including a supply of fire extinguishing fluid and a fire detector. The connection of the individual control circuits provides a control circuit network that automatically initiates extinguishing fluid discharge from all units in response to fire detection by any single unit. The main object of this paper is to provide an automatic fire extinguisher system which eliminates the above described disadvantages of the prior arts. The main part of this task is the involvement of a microcontroller, which may be considered to the nucleus of the whole system. We established a closed-loop feedback system with a microcontroller which senses the temperature sensor, smoke detector signal, and send it to the solenoid valve through some control circuits to maintain the magnitude of the temperature to a certain limit. Fire extinguisher is an active fire protection device used to extinguish or control small fires, often in emergency situations. Typically, a fire extinguisher consists of a handheld cylindrical pressure vessel containing an agent which can be discharged to extinguish a fire. One automatic fire extinguisher placed at a desired location within a region wherein automatic extinguishing should be affected when fire occurs there. One fire extinguisher including integrally a bomb containing a fire extinguishing gas under pressure and a gas jetting nozzle connected through a valve to bomb. One fire sensor arranged at a desired location within said region, and an intermediate electric power supply source connected to said automatic fire extinguishing system. One fire extinguisher being provided with a relay to receive an actuating signal from outside and an electromechanical means for opening said valve, a gas jetting detecting switch for detecting gas pressure in bomb, and a unit control circuit for controlling the actuating of fire extinguisher. Unit control circuit comprising a series circuit provided with an electric actuating circuit of opening means and an on or off switch, which is controlled by relay in a condition of connecting in a series. A terminal of series circuit connected to a terminal of intermediate power supply source, a switch means of a gas jetting detecting switch for interrupting power supply to a series circuit in response to reduction of internal gas pressure in said valve, and for simultaneously outputting an electric potential of the other terminal of intermediate power supply source to an output terminal of unit control circuit. Switch means connected to the other terminal of said series circuit and the other terminal of said intermediate power supply source. Relay of said fire extinguisher being capable of receiving a fire signal issued from the fire sensor. Arduino microcontroller is a popular open source hardware platform with a versatile and user-friendly interface. It is equipped with a variety of sensors and can be programmed to perform complex functions, making it ideal for applications that require precise control and automation. The fire sensor is a critical component of the automatic fire extinguisher system as it detects the presence of fire by sensing the heat, smoke or fume. The automatic fire extinguisher system works by the first detecting the fire using the fire sensor, which sends a signal to the Arduino microcontroller. The Arduino microcontroller processes the signal and activates the extinguisher by releasing the fire suppressor. The extinguisher's release is achieved using a solenoid valve, which is controlled by Arduino microcontroller. The solenoid valve acts as a switch that opens and closes, allowing the fire suppressant to flow or stop. A solenoid valve is an electromechanical valve for use with a liquid or gas control by running or stopping an electric current flowing through a solenoid, which is a coil of wire, thus changing the state of the valve. The operation of the solenoid valve is similar to that of a light switch, but typically controls the flow of air or water, whereas a flow of electricity. A heat is commonly used name for transducer, generating a signal that is proportional to the local heat flux. This heat flux can have different origins, in principle convective, radioactive as well as conducting heat can be measured. A relay is an electrical switch that opens and closes under the control of another electrical circuit. In the original form, the switch is operated by an electromagnet to open or close one or many sets of contacts. The fire suppressant used in the automatic fire extinguisher system can vary depending on the application and the type of the fire being detected. The fire suppressant can be a foam, powder or gas that is stored in container connected to the solenoid valve. When the solenoid valve opens, the fire suppressant is released, smothering the fire and preventing it from spreading. One of the benefits of an automatic fire extinguisher using a fire sensor and an Arduino microcontroller is that it can be easily customized to suitable specific needs. For instance, the system can be configured to fire sensors, allowing for a more extensive coverage area. Additionally, The Arduino microcontroller can be programmed to adjust to the sensitivity of the fire sensor, ensuring that the system detects a fire in its early stages. Another benefit of automatic fire extinguisher, using a fire sensor and an Arduino microcontroller, it is very cheap. The Arduino microcontroller is an affordable and readily available component, and the fire sensor can be purchased for a relatively lower prices. This makes the automatic fire extinguisher system accessible to many people and organizations that may not have the resource to invest in traditional fire suppression systems. In conclusion, automatic fire extinguisher using a fire sensor and an Arduino microcontroller is an innovative of fires. By detecting the presence of fire and releasing a fire suppressor, the system can help reduce the risk of injury, loss of property, and even death. Its customization option make it an attractive option for many individuals and organizations looking to invest in fire prevention. Now let's see the model and the simulation. This is the circuit in Tinkercad of our project. Here we define the alarm buzzer and servo motor. Int read is to get the input from the temperature sensor. Serial.print is to print the values from the sensor in serial monitor. Now we are giving conditions in such that if the temperature is above 80 degrees Celsius, then the alarm starts to blow and the servo motor starts to run. Else, if the temperature is below 80 degrees Celsius, then the buzzer and the servo motor both are kept off. Now let's see the simulation. Now the temperature is below 80 degrees Celsius.